Hey guys, Mr. Backward here. In this video, we're going to look at limits by direct substitution. So the way direct substitution works is if you're looking at the limit of some function as x is approaching c, direct substitution says that you can just take that c value and plug it into the function itself and figure out what that answer would be, and that'll be your limit. And this works for polynomial functions, and it also works for rational functions as long as that denominator is not 0. So for example, if we wanted to look at the limit of 3x minus 2 as x is approaching 2. This is a polynomial function, so I can just take that 2 and directly substitute it into that function for x. So we would get 3 times 2 minus 2. Well, 3 times 2 is 6, minus 2 is 4. So this limit would just equal 4. So we're going to find a couple of limits. So in number 1 here, we're going to find the limit of x squared plus x minus 6 as x is approaching negative 1. If I were to directly substitute that negative 1 in for those x's, I would get negative 1 squared plus negative 1 minus 6. Well, negative 1 squared is 1, and if I add negative 1 to that, that zeroes out. And if I take that and subtract 6, I get negative 6 as my answer. So this limit is negative 6. Take a look at this example. We've got a rational function, so the limit of x squared plus x minus 6 being divided by x plus 3 as x is approaching negative 1. If I do my direct substitution here, the first thing that I need to check is to make sure that that denominator would not be 0, because you can never have 0 on the bottom of a fraction. It won't end up being 0, so we're safe to do the substitution here. So we would have negative 1 squared plus negative 1 minus 6 over negative 1 plus 3. Well, negative 1 squared is 1, plus negative 1 is 0, minus 6, so the top is negative 6. On bottom, I have negative 1 plus 3, which is 2. Negative 6 divided by 2 is negative 3, so this limit would just be negative 3. That's going to be it for this video. Thanks for watching.